Honors geometry, sorry about that. Last one I want to show you. So it says, prove the following theorem about rhombuses using coordinate geometry. If a parallelogram is a rhombus, then its diagonals are perpendicular. Show that parallelogram ABCD is a rhombus, has 4 congruent sides first. Okay, so again, that's the first thing I want you to do is make sure this guy is a rhombus. So let's do that here. I'm going to do it up here, and then I'll just put the answers down below. So to show that it has 4 congruent sides, I must use the distance formula, right? So again, to find AB, I need to, AB. I'm going to take B's coordinates and subtract A's coordinates. So 0 minus negative A squared plus B minus 0 squared. That's going to be 0 plus A, which is just A squared, and this is just B squared. So this is A squared plus B squared. Now listen to me very carefully. Last year's honors did not. Square roots are not distributive. This does not equal A plus B because you took the square root of each. No, it doesn't. This is what it is. It's just that. If you had the square root of A squared, B squared, then it would be AB because that's over multiplication and it is distributive. Okay, so keep that the way it is. All right, BC. So we're going to take C's coordinates minus A coordinates. C's coordinates minus B coordinates. So A minus 0 squared plus 0 minus B squared. Well, A minus 0 is just A, so this is just A squared. Now, 0 minus B is negative B. But what's going to happen when you square negative B? When you square negative B, the negative is going to go away, and it's just B squared again. So it's the same thing, square root of A squared plus B squared. And again, it's not A plus B. All right, CD. We're going to take D minus C's coordinates. So 0 minus A squared plus negative B minus 0 squared. 0 minus A is negative A, but again, when you square negative A, it's going to turn positive. Same thing here, negative B minus 0 is negative B, but when you square it, it's going to turn positive, B squared, and that's inside a square root. And then DA or AD, however you want to call it, I'm going to do A minus D's coordinates, so that's negative A minus 0 squared plus 0 minus negative B squared, all inside a square root. So this is negative A squared, which is positive A squared. This is 0 plus B now, so that's just B squared, and that's under square root. So I'm going to take I'm not going to take a picture. So all of them are A squared plus B squared. This is in fact a rhombus because all of the side lengths are the square root of A squared plus B squared. All have the same side lengths. Okay, so I'll come down here. So we're going to do the side lengths. Again, this is to prove that it has 4 congruent sides. So AB equals root of A squared plus B squared. BC equals the square root of A squared plus B squared. CD equals the square root of A squared plus B squared. And DA or AD equals the square root of A squared plus B squared. So that means you have 4 congruent sides and you are a rhombus. Great. Okay, so you verified it's a rhombus. So now how are you going to show that the diagonals are perpendicular? Well, to show that something is perpendicular, you need to use their slopes. Remember that perpendicular lines have opposite reciprocal slopes. So we need to show that the slope of AC and BD are opposite reciprocals. That will make them perpendicular. Okay? So let's do that. Let's find the slope of AC using the slope formula. Y's. Let's do 0 minus 0. And X's. A minus negative A. Well, 0 minus 0 is 0. A minus negative A is A plus A, and that's 2A. But the top is 0, so that slope is 0. And you should have maybe known that because AC is horizontal. Now let's do the slope of BD. Y's, I'll take, let's do B minus negative B. That's B minus negative b, and 0 minus 0. Well, b minus negative b is b plus b. That's 2b. 0 minus 0 is 0. Uh-oh, the bottom is 0. That means this is an undefined slope, and that is the slope of a vertical line. And of course, a horizontal and vertical line are perpendicular. We just showed that these diagonals are perpendicular. So the slope of AC was 0 over 2a, which is 0. And the slope of BD was 2b over 0, and that is undefined. Let me take a picture. Okay, so I took my picture, so now let me move to the bottom here. So again, now I'm going to look at slopes, and it's the slopes of the diagonals. So the slope of AC equaled 0 divided by 2a, which was 0. And the slope of BD equaled 2b divided by 0, which was undefined. And I'll draw an arrow. So this does mean that the diagonals, segment AC, is perpendicular to segment BD. And that is what you wanted to prove. The diagonals are perpendicular. Done. And there you go. All right, so again, they're not difficult in my opinion. It's just a little bit weird, and you can do some wrong things in algebra. Don't do them. Okay? All right. Have fun. Good luck.